back to my channel. So today we are going to talk about free fall. What do I mean by free fall? See, when an object is falling down, we are going to look at the forces acting on that object. It is the gravitational pull by the earth, right? It is the upthrust by the air which is acting upwards, and it's the resistance with air. I have already explained all these forces in my previous video. You can go and check it out. Okay. So what do I mean by the free fall? Free fall means when an object moves under the influence of gravity alone. Okay. That time it is said to be in free fall. That means the only force which is acting on that object is the gravity. So we can think when all this must be happening. See, when I am standing here or whenever I drop something, I do have the resistance by the air, right? I do have the upthrust by the air. So what I see is that the object is falling down, okay? By free fall, I mean everything is floating, okay? Things are floating. When all this must be having, basically I am talking about spacecraft, okay? In spacecraft, what we see, they have weightlessness. And why? Weightlessness means what? We do not feel the weight of our body. Why? See, when the spacecraft is above the earth, okay, acceleration is still there, right? Due to gravity, if my spacecraft is here, so it has a height h. I agree that this has reduced, acceleration due to gravity has reduced, okay, but it is still there. Acceleration due to gravity in the spacecraft is only, suppose at a particular height in which is going to orbit around the earth, is only 11% less. Whenever acceleration due to gravity is there, that means I have my weight is equals to mg. I should feel my weight, okay? But why are we not feeling my weight in the spacecraft? See, when I have my spacecraft, it is in the free fall. The only force which is acting in the spacecraft is the gravitational force, okay? So I have this my spacecraft. The only force acting is gravity alone here. So the velocity is same for everything. Velocity is same for everything. So if I leave something down, okay, it is going to appear stationary to my eyes because it is also going to be at the same velocity. Suppose I am dropping this duster in the spacecraft, it is also going to have the same velocity which I am having. That's why it appears floating for me, okay? And that's what I mean by weightlessness in spacecraft. Weightlessness, okay, in spacecraft is due to the free fall, okay? And due to the free fall, the velocity is there, but it is same for everything, and we feel everything is floating, okay? Everything is constant, nothing is having weight, nothing is moving in front of me, okay? So next, see, in the previous video, what we saw is what? The acceleration due to gravity is what? G is equal to gm upon r square. So what is my weight? Weight is nothing but mass into acceleration, and this acceleration is due to gravity. So why does the weight of an object changes on different planet? See, basically according to this, substitute this value of g. What it becomes for me? G capital M small m upon r square. Okay, the universal gravitational constant is constant and this mass is constant. But this ratio m upon r square is different for different planets, right? You agree? Different for different planets, right? Mass is different of different planets. That's why weight of an object is different for different planets, okay? Next, we are going to talk about, this is a very important question, you must remember this. We are going to talk about this kinematical equations, okay? What do I mean by the kinematical equations? we have three kinematical equations. First is what? V is equals to U plus gt. Okay? This acceleration I am taking due to gravity. So S is equals to ut plus half of gt square, and v square is equals to u square plus 2gs. Okay? So if my initial velocity is equals to 0, so then what my kinematical equations become? V is equals to gt. That means the velocity is directly proportional. Okay, the velocity is going to be proportional to the acceleration due to gravity and the time duration. Second, it's going to be proportional to, this becomes 0, right? So S is equals to half of gt square. Okay? And third is nothing but v square is equals to 2gs. So these are the kinematical equations when you have the initial velocity to be equals to 0. Okay. So if some question is going to come related to free fall, it would be why there is weightlessness in the spacecraft. Okay, you have to give the reason why is it there. Even the force acceleration due to gravity is acting, still weightlessness is there because in the spacecraft everything is under free fall. In free fall, everything is at the same velocity. That's why things appears to be floating in the spacecraft. Okay. So this is what we were supposed to discuss about free fall. So if you like my video, do give a thumbs up, subscribe to my channel.